What is harmonic motion? Harmonic motion is a periodic and constant motion that goes back and forth through an equilibrium between a maximum and minimum point. The harmonic motion keeps a constant time interval throughout each period. It can be modeled with either sine or cosine. The most obvious example of harmonic motion in the real world would be string instruments, but it is nowhere near limited to just that. It can also be found in the back and forth motion of swings, a cradle, ocean waves, and even hearing. If it wasn't for harmonic motion, you wouldn't be able to hear me right now. So, how is all of this connected to my sunlight project? I made trigonometric functions based off the harmonic data of the sunlight in Bangkok. The way I did this was by first creating a scatter plot of the data. Then, I found functions of the form a sine bx minus c plus d and a cosine bx minus c plus d that best fit the scatter plot of the data. Each piece of a trigonometric function gives off a unique effect to the trigonometric model. Our d affects where on the axis the line of equilibrium will be. A affects the amplitude of the model. B affects the horizontal stretch or compression of our model. And finally, C represents the horizontal shift of the graph. In a real-world example of harmonic motion, a trigonometric equation can be the model for all sorts of things, like the string instruments and swings mentioned before. The equation can help in predicting a variety of things such as velocity and acceleration at any point on the wave. So finally, what is the importance of modeling data? The reason modeling data is so important is because it allows us to make a more simplified representation that helps greatly in visualizing different aspects of our data. It can help us make new insights and envision new things about our data.